Welcome you all to the course Database Management System. Myself Muhammad Asifuddin Mondol, Assistant Professor, Department of Computer Science and Engineering, Northern Technology. And this is lecture number 23 of this particular course. These are the topics which I am going to cover during my lecture. First, I will discuss about the concept of functional dependencies, and then I will discuss the first normal form in normalization. In short, 1NF. So before discussing one, let's know what is functional dependency. As we know, RDBMS, relation or a table, contains multiple attributes, and these multiple attributes have relationship among themselves in some or other way. Or we can say that these attributes have some kind of dependencies among themselves. Now, these dependencies or the relationship among these attributes can be represented in the form of functional dependency. And functional dependency can be represented in that form: x arrow y. That is how functional dependency is represented. Now, what does it mean? Or we can say how to read out that notation. X arrow y means x functionally determines y, or we can say that y is functionally dependent on x. But when we can say that y is functionally dependent on x, or x is functionally determines y, if for a particular value of x, if there is a unique value of y, then we can write x arrow y. So a attribute or set of attribute x functionally determines attribute or set of attribute y if the value of x determines unique value of y. So in a simple way, we can say that for a particular value of x, if there is a unique value of y, then we can write x arrow y. That means then we can say that y is functionally dependent on x, or we can say that in other way, x functionally determines y. Basically, function with the help of functional dependency, actually we are imposing a constraint between two set of attributes. With the basis of this functional dependency, we can define the normal form for relations. And there is also a formal definition of functional dependency. So x or y holds if whenever two tuples have same value for x, they must have same value for y. That means if we have two tuples t1 and t2 in any relation instance, then we can say x or y if for the tuple t1 the value of tuple t1 for attribute x is same as the value of t2 against the attribute x, then obviously in the relation the value of t1 against the attribute y is same as the value of t2 against the attribute y. As I have already mentioned, x or y in R specifies a constraint between two set of attributes x and y. And another point is that if FDs or the functional dependencies basically are derived, how we can write it, how we can derive, how we can determine x or y. Actually, these FDs are derived from the real world perspective. That means on how two attributes are related with each other in real world. With the help of that perspective, we can derive the functional dependencies. Let's take an example of functional dependencies. Before that, consider these two relations emp underscore dbt with the following attributes: email, social security number, birth date, address, department number, department name, DMG or SSN. So how these attributes are related to each other can be represented in functional dependency. Or EMP project have following attributes. How these attributes are related to each other can be represented with the help of functional dependencies. Now, SSN, the example based on the previous relation which we have seen in the previous slide, we can write SSN arrow ename means ename is functionally dependent on SSN. So we can write when a particular value of SSN if there is a unique value of ename. So can we write check based on the previous slide. So SSN arrow ename means, and I'm writing it here. SSN, let me write it. SSN arrow ename first consider this one. Whether can we write this one? Ename is functionally dependent on SSN. Let's check it out based on the dataset. This implies that ename is functionally dependent on SSN. That means for a particular value of SSN, if there is a unique value of ename. Suppose if you consider the SSN 1, 2, 3, 4, 5, 6, 7, 8, 9, this is the value of SSN. Is there unique value of ename or not? Yes. For that particular SSN, there is a unique value, Smith John B. So this is the right FD. So this FD holds. This functional dependency holds on this relation. And next, can we write SSN arrow birth date? Means birth date is functionally dependent on SSN. We can write it if for a particular value of SSN, if there is a unique value of birth date. So as per real world perspective, is it true or false? This means for SSN correspond to a social security number of the particular employee, and definitely a particular employee have a single birth date. So that means for a specific SSN, definitely we should have a single birth date. So for a particular value of SSN, there is a unique value of birth date. So this also holds, as this holds, and this functional dependency also holds or true on that relation. Now question is whether the reverse is true or not. That means can we write that way? Means birth date arrow SSN. That means SSN is functionally dependent on birth date. Is it true or false on that relation? We can write it if for a particular value of birth date, if there is a single SSN, then we can write that way. Let's check whether is it true or false. In real world, what happened? More than 2 employees may have same birthday. For example, like employee X has a birthday 5th January, employee Y also has a birthday on 5th January, and suppose the employee X SSN is 1, employee Y's SSN is 2. So if you provide birthday, say provide the value of birthday is 5th January. So is it providing a unique SSN value? No. If you provide birthday 5th January, then it has two SSN value, 1 and 2. Means SSN 1 corresponds to employee X and SSN 2 is the employee Y. So for a specific birthday 5th January, we will getting two SSN value 1 and 2. So SSN is not functionally dependent on birthday, and it is represented that way. The notation is you have to strike it out on the arrow. So SSN is not functionally dependent on birth date, but birth date is functionally dependent on SSN. Similarly, the other examples are P name, P location. As a combination, they are functionally dependent on P number. So we can write it if for a particular project number, if there is a unique combined value of p name and p locations are there, then we can write p number arrow p name comma p location. You can check it out based on the data set provided on the relation which is shown in my previous slide. As I have mentioned that the FD is a property of the attribute and it's kind of constant, and that constant must hold on every relation instance. Means this FD constant must hold for every tuples those belongs to that particular relation. Then only we can say that the particular FD is true or the holds on that relation. And another very important point, suppose if K is a attribute and is a key attribute, means if K is a key of relation R, and as the K is a key, that means with the help of K we can uniquely identify a particular record. That means we can say that K functionally determines all attributes in R. This is a very vital point. As with key functional, as the key uniquely identifies a particular record, means it uniquely identifies or a particular value of K, it particular identifies the attributes. So we can say that K functionally determines all attributes in R. Now, how to define FD on a particular relation? Basically, in order to define the functional dependencies, we need to understand the meaning of the attributes involved in a relation and the relationship between them. And basically, the functional dependency defining on a particular relation are based on real world perspective, based on our perception, how the attributes, how two set of attributes are related with each other in real life. Based on that, actually, we can define our functional dependency. For example, in real world, for every employee, there is a unique SSN. So, in employee relation, em employee name should be dependent on SSN. And given the instance of a relation, means suppose there is a relation and the relation is populated with a set of data, then if the set of by observing this set of data or the set of population, we can conclude that a particular FD may exist between certain attributes. So we can conclude that FD may exist between the set of attributes by observing the instance of a relation, but you cannot surely say that the FD is there. Consider another example. Suppose teach is a relation, and this is the population relation teach, means this is the data set given. Now based on this given data set, we have to determine what are the functional dependencies may hold and what are the functional dependencies does not hold. For example, to consider this one, text arrow course, means we have to check whether course is functionally dependent on text or not. Now text arrow course, we can write it, means course is functionally dependent on text if for a particular value of text, if there is a unique value of course. So based on this data set, suppose text is Bertram. For the value Bertram, if there is unique value of course is there or not? Yes. For Bertram, there is only one value, data structure, no other value is there. So yes, we can write check for another record. Say the text value is Martin. We have to check whether for Martin, if there is a single value of course is there or not. Yes, for Martin, there is unique value is data management. Similarly, for Hoffman, there is a single value course compiler. For Horwich, there is a data structure course. So this functional dependency course. Now we check whether reverse is true or not, means this one. Text is functionally dependent on course. Can we write it based on this data set? Let's check out suppose course consider data structure. So for a particular course data structure, can we are getting a single value of text? No, for a data structure, we are getting two text value. One is but from, and for data structure, we are again getting another value for which. That means for a particular value of text, there is no unique value of text. For a particular value of course, we are getting multiple value of text. For example, for data structure, we are getting two text value. One is but from, another one is how which. So course arrow texts are ruled out. That means course arrow text, this functional dependency doesn't hold on the relation teach based on given population. Let's check another example. Teacher arrow course means course is functionally dependent on teacher. Can we say that this functional dependency holds on the relation teach? Let's check. Suppose the teacher is Smith. Can we are getting a unique value of course? No, because for value of teacher Smith, there is a corresponding two course. One is data structure and another one is the data management. That means for a particular value of teacher Smith, we are getting multiple course. So teacher arrow course doesn't hold. This functional dependency doesn't hold on relation teach. But whether the reverse is true means course arrow teacher is true. Yes, first we may say that it's true because if you provide course data structure, there is a single value of teacher Smith. No, again, the course arrow teacher is also doesn't hold because for a course single value data structure, we have two value of teacher Smith and Brown. So course arrow teacher it also doesn't hold. Now the next point is the concept of normalization. As I have already discussed in my previous lecture, the normalization. Actually, normalization is a process by which we can simplify the relationship among the records by analyzing the functional dependencies. Means with the help of functional dependencies, we can simplify the complex relationship. And objective of normalization is to reduce the data redundancy in a relation, and second objective of normalization is to reduce the insertion, deletion and updation anomalies present in a database. Now normalization have multiple normal form 1NF, 2NF, 3NF, 4NF, BCNF, 5NF. So in this lecture I will discuss about only 1NF. So 1NF, a relation using 1NF if for a particular record every attribute should have a single value as well as the value should be atomic in the sense that value cannot be further decomposed. Again I am repeating, a relation is in one if and only if for every record or for every tuple, if all the attributes contains a single value as well as the value should be atomic. That means 1NF, we can say that 1NF disallows composite attributes, multi-valued attributes. Means suppose for a particular record, suppose an attribute has a set of value, means multi-value attributes, then then the relation is not in 1NF. So that means 1NF disallows the multi-valued attribute, it disallows the composite attribute, as well as it disallows the nested relation. So all these things will be discussed with the help of some example. Suppose this is the table given department with the following attribute: department name, department number, MGR underscore SSN and delocation. Here department number is the primary key and the function, and this arrow with with the help of this arrow actually we are defining the functional dependencies. Now the arrow towards the name towards DMGR SSN and towards D location. From D number means D name, DMGR SSN, D location all are functionally dependent on D number. Now let's populate the data, populate the relation with the set of data. Suppose the department number is 5, department name is research, and the department manager's social security number is this one. And suppose the department research belongs to different location. Suppose Bellary, Sugarland, and Houston. This in these three locations, research department has the buildings. Similarly, for example, administration department number is 4. This is the social security number of department manager, belongs to Stafford location. Now, if you look at that attribute D location for all the record for all the tuples, then we can easily get that for record research against the attribute D location we have multiple value. That means the attribute D location is a multi-valued attribute, but 1NF disallow this multi-valued attribute. So we can say that the relation department is violating the 1NF, means the relation department is not in 1NF. Why? Because the department relation has an attribute D location which is a multi-valued attribute, and if a relation has a multi-valued attribute, then the relation is not in 1NF. Similarly, that particular relation, that scenario also be represented that way. For example, and how this relation is considered as bad relation, we can easily realize that if we convert that table into this one. In this one, suppose department name is research, department number 5, DMGRSSN is this one, and as the research department located in Bellary, Sugarland, and Houston, so these are the three separate entity. For these three separate location, three unique location, three different location. This set of information is repeated for Bellary, Sugarland, and Houston. But for these three different locations, the same information, the research 5 and the DMGSSN, this set of data are repeated multiple times. So that means we can easily get that there is a huge data redundancy or exist in the relation department. So this is not in 1NF and this is a bad design. So we have to convert the relation into 1NF. So how to convert the relation department into 1NF? So what we have to do to convert it into 1NF is that to convert it into 1NF we have to break down the department relation. Now how to break it up? The attribute which is a multi-valued attribute, so that multi-valued attribute has to be removed from the original relation department, and we have to place that particular multi-valued attribute D location into a separate relation along with the primary key. So move to the next slide. Here is that. So remove the multi-valued attribute from the relation and place that attribute along with the primary key in a separate relation. So if you go back to the previous slide, D name, D number, DMGRSSN, this is all these three attributes are not a multi-valued attribute. So these three will be intact in the relation department. So these three attributes will form a relation. So this one, department name, department number, and DMGR SSN, these three attributes constitute a single relation where D number is the primary key and the multi-valued attribute is D location that should be placed in separate relation along with the primary key D number. So the department original relation was department. Now the original relation department is break into two sub relation. One is this one, consists of D name, department number, DMG, SSN, and another relation is D number and D location. So that is how we can convert the any relation into one and n. Let's take another example. Suppose the relation is EMP underscore project with the attribute SSN, social security number, employee name, P number is the project number, and hours. And these are the data set. So SSN is, suppose the SSN particular employee is 1, 2, 3, 4, 5, 6, 7, 8, 9, whose corresponding employee name is John Smith. And based on this data, we can see that that particular employee works in two projects. One is the project number 1, for which he works 32.5 hours, and the same person works in another project whose project number is 2 and works for 7.5 hours. So if you look at the record, other record also, we can conclude that P number attribute has multi-valued attribute. Multiple values are there for a particular record. Similarly, the attribute hours is also a multi-valued attribute, means multiple values are there for a particular record. So it is not in 1NF. So what we have to do, we have to convert that relation into 1NF. So what we have to do, we have to remove the multi-valued attribute from the original relation. So you have to remove the P number and hours, these two attributes, as they are the multi-valued attributes. So you have to remove that this multi-valued attribute from the original relation PROJ, and you have to place these two multi-valued attributes into a separate relation along with the primary key. So one relation will be SSN and ename, where SSN is the primary key. So this one, and these two P number and hours will be replaced and placed into a separate relation. Here is that P number and hours placed in separate relation along with the primary key SSN, where SSN is the primary key. So that is how we can convert any relation into one NF. Also, further that particular relation further EM. So this was the original relation. This is breakdown into two sub relation, EMP underscore PROJ1 and EMP underscore PROJ2. So this is all. After converting it into one, we are come up with these two relation. Now still we can break down the EMP underscore PROJ1 to make it in 1NF. Further we can fine tune it. Why? Because in attribute ename, employee name, this particular attribute is not atomic, and a relation is not in 1NF if attribute has a data which is non-atomic. If you remind that a relation R is in 1NF if it doesn't have multi-valued attribute, also if it doesn't have, again I am repeating, a relation R is in 1NF if it doesn't have the multi-valued attribute as well as if it doesn't have atomic value attribute. For example, here in that relation, in these two relation, no in that relation multi-valued attributes are not there, because these multi-valued attributes are totally separated and place them into a different relation. But if you look that particular relation SSN and ename, here ename the value is Smith comma John B. So there is a concept of first name last name are there. So this is not basically a non-atomic data. We can break it down. So ename is a composite attribute because ename consists of first name and last name. So that data, based on that data, we can say that this is not in 1NF. So further we can break it up. It is more perfect if we write in that way: SSN arrow first name arrow last name, then it will be in more accurate 1NF. And these are the references you may go through for more details.